History of the Atom Part 2 by Reid and Rachel. Rutherford's model was incorrect because he proposed that electrons may move anywhere within the volume of space around the nucleus. But first, let's go back to the year of 1900 to see what Max Planck had to say. Max Planck was born in 1858 and died in 1947. He was a German physicist most known for his quantum theory, which earned him the Nobel Prize in Physics in 1918. He developed the quantum theory of energy. Planck said that energy was given out in small packets he called quanta. The energy of the packet is the equation E equals hv, where E is the energy, h is Planck's constant, and v is the frequency. Just to be clear, Planck believed the energy in the packet was the frequency times the constant he developed himself, we now call Planck's constant. Our next scientist is the very well-known Albert Einstein, who created the famous equation E equals mc squared. This famous equation was called the theory of relativity, which relates mass to energy. Einstein also worked on the Brownian motion. He did not mathematically create these rules, but concluded that it proves atoms exist. Put simply, an example of Brownian motion is air or water particles bouncing off each other, making the particles look like they are moving randomly.
Niall Bohr's work from 1916 to 1962 showed how electrons were in orbits of fixed proportions. Electrons could enter an orbit of greater or lower energy if they released or absorbed energy. The energy could be light, also known for the liquid drop model, which explained how nuclear fission worked. The model was based in essence a drop of water representing an atom. When energy, or in essence a neutron, was added to the water puddle, it would start to form a dumbbell shape with almost identical amounts of water on each side. Now, if given enough energy, or in this case that neutron being added, it would split into two almost identical amounts of water, and the two identical amounts of water would represent two atoms it created, or were formed. Werner Heisenberg, born 1901 and dying 1976. He is most known for his Heisenberg uncertainty principle, which uses quantum mechanics and matrices. Matrices being a part of math and are sets of numbers that have special means of being added, subtracted, multiplied, and divided. His principle in essence stated that the more you knew about a particle, so such as an electron, let's say you wanted to find the exact location of it, you would not be able to find the momentum of it, and vice versa. So if you wanted to find the momentum of an electron, you'd not be able to find the exact location of it. And this is in essence of what he created. Similar to Schrödinger's ideas, except that Schrödinger's encompasses a larger area of particles. Born 1887 and dying 1962, Erwin Schrödinger's biggest contribution to chemistry was finding an equation that showed electrons how they move in wave-like motions and how they are nearly impossible to find the exact location of. But his equation predicted where they most likely will be. This was revolutionary, as it did not say the electrons would be in a certain area, point, or orbit, but rather it showed the probability of it being in an area and the percentage of it. This equation is still used in wave mechanics today.
A lot of hard work went into developing the atomic model. Thanks to all of the scientists and their discoveries, we have a pretty good idea of what the modern atom looks like today. The atom is made up of protons, neutrons, and electrons. Electrons are always in constant motion around the nucleus. The nucleus is the core of the atom containing the protons and the neutrons. And the protons and neutrons are in the core of the atom called the nucleus. And even smaller particles called quarks are within the protons and neutrons.